For centuries, humans have stared at the skies in awe, watching birds glide effortlessly through the air and wondering, could we ever fly like them? Asterisk. Flight has always been humanity's ultimate dream, from the myth of Icarus in ancient Greece to Leonardo da Vinci's sketches of flying machines in the 15th century. People imagined strapping wings to their backs or building complex contraptions to lift themselves into the sky. For thousands of years, this dream remained just that, a fantasy. Yet, as technology progressed, the impossible began to feel achievable. By the 19th century, inventors across the globe were exploring ways to conquer the sky using science, physics, and innovation. The Industrial Revolution had transformed society. Railroads, steam engines, and mechanized factories demonstrated that humans could harness energy to perform incredible feats. But the sky remained unconquered. Early flight attempts began with balloons and airships. The Montgolfier brothers' hot air balloon in 1783 lifted humans into the air for the first time. It was a marvel, but balloons lacked control, they drifted wherever the wind carried them. The real challenge wasn't just getting off the ground, it was steering, sustaining flight, and eventually, mastering the art of controlled movement through the air. The mid-19th century saw systematic approaches to flight. Sir George Cayley, an English engineer, identified the four fundamental forces of aerodynamics: lift, drag, thrust, and weight, and constructed gliders that could carry humans for short distances. In Germany, Otto Lilienthal performed over 2,000 glider flights in the 1890s, meticulously documenting his observations. His work demonstrated the importance of stability, wing shape, and control surfaces in flight. Lilienthal's tragic death in 1896 underscored the risks involved, but his contributions laid critical foundations for future aviators. Meanwhile, in America, Samuel Pierpont Langley, an astronomer and head of the Smithsonian Institution, pursued powered flight. He constructed small unmanned models called aerodromes, which flew successfully over water. Encouraged by this, he received funding from the U.S. government to build a full-sized manned version. Yet, in 1903, Langley's machine failed dramatically, plunging into the Potomac River just seconds after launch. Newspapers ridiculed him, and many concluded that human flight was unattainable. Nevertheless, two brothers in Dayton, Ohio, were studying these developments carefully, preparing to challenge conventional wisdom. Dayton was an industrious city at the turn of the century. Factories buzzed, new technologies were emerging, and bicycles had become a popular innovation. The Wright brothers Wilbur and Orville ran a small bicycle repair shop. Their work demanded mechanical skill, precision, and an intuitive understanding of balance skills directly applicable to aviation. They observed the world with curiosity, dissected mechanical problems, and built their own inventions. Their genius lay not in formal education but in the meticulous application of practical knowledge to complex problems. The Wright brothers began experimenting with gliders in the late 1890s. Their early designs were informed by careful study of previous experiments, including those of Lilienthal and Chanute, an influential engineer and aviation researcher. Unlike many contemporaries, the Wrights emphasized control over mere lift. They developed a method called wing warping, which allowed a pilot to tilt the wings and steer the glider. This innovation addressed the central challenge of flight, maintaining balance and direction in the air. The brothers also built a wind tunnel to test hundreds of wing shapes, gathering precise data to inform their designs. Their approach combined scientific observation, mechanical skill, and relentless experimentation, a rare combination at the time. By 1900, the Wright brothers had gained valuable experience through glider flights at Kitty Hawk, North Carolina. The site offered consistent winds and soft sand dunes for safe landings. Their flights were short and sometimes ended in crashes, but each attempt contributed to a growing understanding of aerodynamics. They carefully recorded measurements, analyzed results, and iteratively improved their designs. This scientific approach distinguished them from other inventors, who often relied on trial and error alone. The breakthrough came in 1903. On December 17, after years of preparation, the Wright Flyer, a powered, heavier-than-air aircraft, achieved sustained flight. Orville piloted the first flight, covering 120 feet in 12 seconds. Later that day, the brothers conducted additional flights, with Wilbur taking one journey that lasted 59 seconds and covered 852 feet. The aircraft was modest by today's standards, a lightweight wooden frame, muslin-covered wings, and a 12-horsepower engine. Yet it represented a monumental leap in human achievement. For the first time, a manned, powered, heavier-than-air machine had flown under complete control. Despite their success, the Wright brothers faced skepticism. Many doubted the authenticity of their claims. Newspapers demanded evidence, and some scientists dismissed the flights as exaggerations. Determined to prove their invention, the brothers continued testing and conducting demonstrations. They refined their designs, built new flyers, and carefully documented each flight, eventually gaining recognition both in the United States and Europe. By 1905, the Wrights had developed a practical flying machine capable of sustained, controlled flights over long distances. Their innovations, wing warping for control, lightweight engines for propulsion, and careful balance of aerodynamic forces, laid the foundation for modern aviation. The world had moved from imagining flight to witnessing it, and the era of the dreamers was giving way to the era of doers. The story of the Wright brothers is not only one of invention but also of meticulous problem-solving. They exemplified the idea that progress comes not from sudden genius alone but from careful observation, iterative design, and the courage to defy conventional wisdom. Their work inspired countless others, setting the stage for future aviation pioneers and ultimately for the military applications that would emerge just a few years later. In retrospect, the significance of the Wright brothers' achievement cannot be overstated. They transformed centuries of speculation into reality. They proved that controlled, powered flight was possible, opening the skies to exploration, commerce, and defense. From a small bicycle shop in Dayton to the windswept dunes of Kitty Hawk, their journey demonstrated that human ingenuity, persistence, and vision could achieve the once impossible. The age of dreamers had culminated in a concrete triumph. Flight was no longer a myth, and humanity had taken its first true steps toward mastering the skies. The world was on the verge of a revolution, one that would change transportation, warfare, and global connectivity forever. The Wright brothers' experiments marked the dawn of aviation, setting in motion technological advancements that would shape the 20th century and beyond. And thus, from curiosity and perseverance, the dream of flight was transformed into reality, a reality that would soon capture the attention of the U.S. military and alter the course of history. Got it? I'll create Chapter 2 in 1,000 to 1,100 words, seamless, fully informative, without repeating Chapter 1. This will continue the narrative from where Chapter 1 left off, focusing on the Wright brothers' transition from experimental gliders to powered flight and their first encounters with the U.S. military. From experimentation to first flight. In the quiet town of Dayton, Ohio, a revolution in the sky was quietly taking shape. Two brothers, armed with little more than ingenuity and determination, were about to transform the impossible dream of flight into a tangible reality. By 1904, the Wright brothers had moved beyond short glider hops into constructing machines capable of longer, controlled flights. Their focus shifted from mere experimentation to practical, repeatable aviation. Lessons learned from Kitty Hawk's sandy dunes had shaped their understanding of aerodynamics, but now they needed a permanent testing ground. In Dayton, they built a makeshift runway in the form of a smooth, flat field, allowing for repeated takeoffs and landings. This was crucial. Controlled flight demanded precision, and crashes at this stage could destroy months of work. The challenge of power was central. Gliders could exploit wind, but sustained, controlled flight required an engine light enough to lift the aircraft yet powerful enough to sustain movement. The brothers collaborated with mechanic Charles Taylor, who designed a custom 12-horsepower gasoline engine. This partnership highlighted the Wrights' approach. They combined theoretical understanding with practical skill, ensuring that every component of their aircraft from propellers to control surfaces was optimized for performance. The result was the Wright Flyer 2, capable of longer flights than its predecessors. The Flyer 2 represented a turning point. In 1904 and 1905, Wilbur and Orville conducted dozens of test flights, gradually increasing both altitude and distance. These flights were carefully documented. Unlike earlier attempts by other inventors, the Wrights prioritized stability and control over simple airborne movement. They measured lift, engine performance, wind effects, and pilot input, creating a systematic record that would later serve as a blueprint for future aviation. By the end of 1905, they had achieved flights lasting over 30 minutes, covering more than 24 miles in total. These milestones demonstrated that powered, controlled flight was not a one-time event but a reproducible achievement. Beyond engineering, the Wright brothers faced the challenge of public perception. Many newspapers and scientists remained skeptical. Demonstrations in Europe became an essential strategy to validate their invention. Wilbur traveled to France in 1908, where crowds gathered to witness controlled flights. His performances captivated audiences, proving that the Flyer could reliably lift, turn, and land. The press coverage was extensive, and the Wrights' reputation as pioneers of aviation was solidified. Meanwhile, Orville conducted flights in the United States, often attracting military observers and civil aviation enthusiasts. It was during this period that the U.S. Army Signal Corps began showing interest. Military leaders recognized the potential of flight for reconnaissance, rapid communication, and strategic advantage. In 1908, the Signal Corps invited the Wright brothers to demonstrate their aircraft at Fort Myer, Virginia. These trials were rigorous. The aircraft had to carry a pilot, sometimes a passenger, maintain stability in varying wind conditions, and perform consistently. The Wrights Flyer passed these tests with remarkable success. Their meticulous attention to detail, combined with systematic trial flights, demonstrated both the feasibility and reliability of powered flight for military use. The Wrights' interactions with the military also highlighted the early logistical and technical challenges of aviation. The Flyer was fragile by modern standards, it required careful assembly and maintenance, and flights were dependent on favorable weather conditions. Pilots needed training to handle the machine's controls, which were unlike anything encountered in traditional land vehicles. Nevertheless, these initial experiments laid the groundwork for structured military aviation programs, demonstrating that planes could evolve from experimental machines to operational tools. One of the most critical innovations of the Wrights during this period was the refinement of their control system. Earlier gliders had used wing warping, which allowed the pilot to tilt the wings for directional control. With the Flyer 2 and later models, this system was perfected, allowing smooth turns and improved stability at higher speeds. Coupled with the lightweight gasoline engine and dual propeller design, The aircraft could now perform precise maneuvers, an essential requirement for reconnaissance or military applications. The Wrights had not only achieved flight, they had mastered the control necessary to make it practical. Another essential element of the Wright brothers' success was documentation. Every flight was recorded with exact measurements of distance, altitude, duration, and engine performance. This meticulous record-keeping distinguished their work from other contemporary aviation experiments. It was not enough to fly once, they had to demonstrate consistent, repeatable results. This scientific approach was critical in convincing military and civilian authorities of the flyer's potential. It laid the foundation for the systematic design and testing protocols still used in aviation engineering today. By 1909, the culmination of these efforts resulted in the first sale of an airplane to the U.S. military. After successful demonstrations at Fort Myer, the Army purchased the aircraft for $30,000, officially designating it Signal Corps Airplane No. 1. This transaction marked a historic milestone. For the first time, an American-made powered aircraft would serve in a military capacity. The aircraft was assigned to Lieutenant Benjamin Foulois, one of the earliest U.S. military pilots, who trained on the machine and oversaw its early operational use. While primitive by modern standards, cloth-covered wings, exposed framework, and a maximum speed of 45 miles per hour, the flyer represented the dawn of military aviation in the United States. The impact of these achievements extended far beyond Dayton or Fort Myer. The Wright brothers' success sparked international interest. European militaries and inventors began to explore aviation with renewed urgency. The concept of airplanes as strategic tools, rather than mere curiosities, gained traction. The Wrights had not only solved the technical challenge of powered flight, they had demonstrated its potential as a practical instrument for reconnaissance, communication, and eventually combat. This period marked the transition from individual experimentation to organized, structured aviation programs, both civilian and military. Crucially, the Wright story in this phase illustrates the importance of perseverance and methodical experimentation. Unlike many inventors who relied on bold but haphazard trials, the Wright brothers combined mechanical skill, careful measurement, and iterative design. Each flight informed the next. Each failure revealed a critical insight. By 1909, their aircraft were not only flying, they were functional, reliable, and adaptable to emerging military needs. The lessons learned during this period would influence aircraft design for decades to come, laying a foundation for the rapid technological advancements of World War I and beyond. By the end of Chapter 2, it is clear that the Wright brothers had achieved far more than the first powered flight. They had transformed flight from an experimental novelty into a practical tool capable of systematic operation. Their work caught the attention of military leaders, inspired global aviation pioneers, and fundamentally altered the trajectory of transportation and warfare. Dayton's bicycle shop had produced not just an invention, but a revolution, one that would lift humanity into the skies and forever change the way the world perceived movement, speed, and possibility. The sky becomes a battlefield. In the early 20th century, the idea that wars could be fought in the skies seemed like science fiction. Yet, as the first military aircraft lifted off the ground, the battlefield was about to be transformed forever. After the U.S. Army purchased the Wright brothers' Signal Corps Airplane No. 1 in 1909, the focus shifted from invention to practical application. The military had never encountered a tool like this before. Suddenly, commanders had to rethink strategy, logistics, and training. How could a fragile, cloth and wood machine be deployed effectively? What skills did pilots need to navigate the skies safely? These questions demanded immediate solutions. The first military pilots faced enormous challenges. Unlike modern airplanes, The early flyers had no standardized instruments. Navigation relied on visual cues from the landscape below, while maintaining control required constant attention to wind, balance, and engine performance. Accidents were common. Many early pilots learned through trial and error, often at great personal risk. Lieutenant Benjamin Foulois, the first U.S. Army officer to fly a powered airplane, exemplified this pioneering spirit. He studied the Wrights manual, trained rigorously, and adapted quickly, setting the precedent for future military aviators. Training was rudimentary but effective. Pilots began with ground-based instruction, learning to assemble and disassemble aircraft, understand engine mechanics, and perform basic maintenance. They practiced taxiing the aircraft, controlling lift at low speeds, and mastering takeoff and landing on makeshift airfields. Only after gaining confidence on the ground did they attempt actual flight. These methods emphasized safety and precision, establishing the foundation of early military aviation doctrine. The strategic potential of airplanes quickly became apparent. Military leaders recognized that aircraft could serve as observation platforms, offering unprecedented views of enemy positions, terrain, and troop movements. For the first time, commanders could obtain real-time intelligence from the air, rather than relying solely on scouts or ground-based reconnaissance. This capability had profound implications. A single aircraft could cover miles of territory in minutes, fundamentally altering how battles were planned and executed. Beyond reconnaissance, early military exercises explored the use of aircraft for communication. Pilots carried messages across distances, effectively functioning as airborne couriers. This was particularly valuable in areas with difficult terrain or where traditional communication lines were unreliable. Even at this early stage, the military began to imagine offensive applications. While weapons had not yet been mounted on airplanes, exercises tested low-altitude maneuvers and coordinated flights, laying the groundwork for future combat aviation. Maintenance and logistics presented another set of challenges. Early airplanes were fragile, sensitive to weather, and prone to mechanical failure. Engines required careful monitoring, wooden frames needed constant inspection, and cloth wings could tear or loosen during flight. Military units established basic repair facilities at airfields, and pilots often performed maintenance themselves. This hands-on approach fostered a deep understanding of aircraft mechanics, ensuring that early military aviators were both pilots and engineers. The early 1910s also saw the first formal aviation competitions and demonstrations. The U.S. Army organized flight trials to evaluate aircraft performance, endurance, and reliability. These events were both practical tests and public spectacles, designed to showcase the potential of aviation to lawmakers, military leaders, and the general public. Competitions spurred innovation, pushing engineers to improve engines, aerodynamics, and control systems. By 1911, the military was experimenting with multiple aircraft formations, understanding how planes could operate together in coordinated missions, a precursor to the complex aerial strategies seen in later conflicts. The influence of military aviation extended internationally. European nations closely observed U.S. experiments with the Wright Flyer, accelerating their own aircraft programs. By the outbreak of World War I in 1914, countries like France, Germany, and Britain had developed dedicated air corps, building on lessons learned from pioneers like Foulois and the Wright brothers. The early adoption of airplanes by the U.S. military positioned the nation to participate in this global shift, even though full-scale aerial combat would emerge only a few years later. Perhaps the most significant legacy of this period was the transformation of military thinking. Before airplanes, battles were fought exclusively on land and sea. Commanders relied on ground reconnaissance, telegraphs, and couriers to make decisions. With the introduction of aircraft, the battlefield gained a new dimension, the vertical. High-altitude observation, rapid communication, and the potential for aerial offense forced a re-evaluation of strategy, logistics, and national defense. The Wright Flyer may have been a primitive machine, but its impact on military doctrine was profound and enduring. This era also highlighted the human element of early aviation. Pilots needed courage, resilience, and adaptability. They flew without modern instruments, navigational aids, or protective gear, often in dangerous weather. Each successful flight was a triumph of skill and daring. These pioneers set a precedent that would define military aviation culture for decades, a combination of technical expertise, strategic thinking, and personal bravery. By 1912, the U.S. military had established permanent aviation units, trained additional pilots, and developed standardized procedures for flight operations. The Signal Corps Airplane No. 1 had been retired, but its legacy persisted in the growing fleet of aircraft, evolving training programs, and emerging airfields across the country. The era of experimentation was giving way to structured, operational aviation, laying the foundation for the more advanced machines that would dominate the skies during World War I. In conclusion, the early years of U.S. military aviation transformed both technology and strategy. From fragile, cloth-covered flyers to organized air units capable of reconnaissance and communication, these developments reshaped warfare. The bravery of early pilots, combined with the vision of inventors like the Wright brothers, demonstrated that flight was not just a technical achievement, it was a strategic revolution. By conquering the skies, the U.S. military had opened a new front in the art of war, one that would continue to evolve with each generation of aircraft. The first chapter of aerial warfare had begun, not with bombs or dogfights, but with observation, experimentation, and the courage to pilot fragile machines into the unknown. By the 1910s, the age of experimentation was fading, and the age of aviation innovation was accelerating at a pace few could have imagined. The sky was no longer just a realm of dreams, it was becoming a strategic frontier. As the U.S. military embraced its first airplanes, engineers and pilots faced the urgent challenge of improving performance, durability, and operational capability. Early aircraft, like the Signal Corps Airplane No. 1, were revolutionary but fragile, limited in speed, range, and payload. To transform flight into a viable military asset, inventors had to innovate across every aspect of aviation: engines, aerodynamics, materials, and flight control systems. One critical area of innovation was propulsion. Early aircraft engines were lightweight and low-powered, often producing less than 30 horsepower. While sufficient for short flights, they restricted speed, altitude, and endurance. Engineers experimented with more powerful gasoline engines, balancing weight against performance. Charles Taylor, who had assisted the Wright brothers, pioneered early solutions, but by the 1910s, multiple companies were designing engines capable of supporting heavier airframes, extended missions, and eventually multiple passengers or cargo. These developments laid the foundation for planes that could serve not only as observation platforms but also as strategic tools in warfare. Aerodynamic research advanced rapidly during this period. Designers studied wing shapes, control surfaces, and fuselage structures to improve stability and lift. Biplanes dominated early military aviation due to their superior lift-to-weight ratio and structural strength. The addition of struts and wires reinforced fragile wooden frames, allowing airplanes to carry heavier engines and additional equipment. Innovations such as ailerons, rudders, and elevators became standard, replacing wing warping systems and improving maneuverability. Pilots could now execute precise turns, climb higher, and fly for longer durations, essential capabilities for reconnaissance and emerging tactical applications. Materials science also played a crucial role. Early aircraft relied heavily on wood and fabric, which were lightweight but vulnerable to weather, stress, and combat damage. Engineers experimented with stronger woods, reinforced frames, and early metal components. By 1913, aluminum and steel began to appear in aircraft construction, enhancing durability without excessively increasing weight. These incremental improvements represented the transition from experimental machines to operational tools capable of surviving in demanding environments. The role of the pilot evolved alongside technology. As aircraft became faster, heavier, and more complex, training programs expanded. Military aviators learned navigation techniques using rudimentary maps, compasses, and visual landmarks. They practiced coordinated maneuvers, formation flying, and emergency procedures. Maintenance training was equally important, as pilots often had to repair engines, fix control surfaces, and inspect structural components in the field. The combination of technical knowledge and flight skill became a hallmark of professional military aviators. By the mid-1910s, aviation exercises increasingly emphasized tactical applications. Observational flights demonstrated how aircraft could monitor troop movements, map terrain, and relay critical intelligence to commanders in real time. Early experiments with signaling devices including flags, flares, and wired telegraphy enabled pilots to communicate with ground units. Although the concept of aerial combat had not yet matured, these innovations hinted at the transformative potential of air power in future conflicts. The international context was equally influential. European nations were rapidly developing their air forces, spurred by the technological advances of inventors and the growing recognition of aviation's military importance. France, Germany, and Britain conducted extensive research into engine design, armament integration, and tactical maneuvers. U.S. military leaders closely observed these developments, recognizing that the coming war in Europe would demand robust air capabilities. This global arms race accelerated domestic innovation, prompting American engineers and military planners to improve aircraft performance and expand training programs. Another notable development was the diversification of aircraft types. Designers began experimenting with specialized roles, reconnaissance planes, trainers, and experimental combat aircraft. Biplanes remained dominant, but monoplanes were emerging, offering improved speed and aerodynamics. Early seaplanes and amphibious aircraft expanded operational flexibility, enabling missions over water and in remote regions. The diversity of aircraft foreshadowed the complex aerial strategies that would define World War I and later conflicts. The challenges of logistics and support were also evident. Airfields required flat, durable terrain for takeoffs and landings, as well as maintenance facilities for repairs. Fuel and spare parts had to be transported and stocked efficiently. Communication between pilots and ground personnel needed refinement. These operational considerations were as critical as technological advancements. Without them, even the most capable aircraft would be ineffective in real-world scenarios. By 1916, the U.S. Army had developed multiple aviation units, incorporating the latest aircraft designs and training methodologies. While the United States had not yet entered World War I, the military recognized that aerial capabilities would soon be essential. Pilots trained rigorously, engineers refined engines and airframes, and strategists began integrating air power into broader military planning. The early experiments of the Wright brothers had evolved into an emerging air force, poised to influence both domestic defense and international conflict. The innovations of this period also established principles that remain fundamental in aviation today: the importance of lightweight, powerful engines, aerodynamic efficiency, control and stability, specialized roles for aircraft, and systematic training for pilots. These principles transformed the airplane from a fragile novelty into a versatile tool with strategic value. The groundwork laid during this era enabled rapid advancements during World War I, when airplanes transitioned from observation machines to armed combatants, reconnaissance platforms, and bombers. In conclusion, the years leading up to World War I were a time of remarkable technological growth in U.S. military aviation. From fragile, experimental aircraft to durable, functional planes capable of extended missions, the evolution of design, materials, engines, and pilot training set the stage for the modern Air Force. The sky had shifted from a realm of fantasy to a strategic domain, and the groundwork laid in this period would shape aerial warfare for generations. The transformation was both technological and conceptual. The military now recognized that mastery of the air could determine the outcome of battles, influence national security, and redefine the nature of war itself. The wings of war had been forged, not in conflict, but in the workshops, wind tunnels, and training fields of early American aviation. The stage was set for the dramatic, high-stakes battles that would soon unfold above the trenches of Europe. As the world descended into a conflict unlike any before, the sky became a new battlefield. For the first time, the United States would send pilots and machines into combat, testing the limits of technology, skill, and courage. When the United States entered World War I in April 1917, its aviation program was still in its infancy. Only a handful of trained pilots and military aircraft were available, and most machines were outdated compared to European standards. American leaders quickly realized that air power would be critical in reconnaissance, artillery spotting, and supporting ground operations. This realization sparked an urgent expansion of aircraft production, pilot training, and tactical planning. The U.S. government established the aviation section of the Signal Corps, which later evolved into the U.S. Army Air Service. This organization became responsible for organizing, equipping, and deploying air units overseas. However, the challenges were immense. Aircraft had to be mass-produced quickly, often under wartime conditions, while training programs had to transform inexperienced civilians into competent combat pilots. American engineers and manufacturers worked tirelessly to build and modify aircraft designs suitable for European battlefields, incorporating lessons learned from French and British aviation pioneers. Early combat missions emphasized reconnaissance. Pilots flew over enemy lines to observe troop movements, artillery positions, and fortifications. This intelligence was invaluable to commanders, who could now plan attacks and defenses with greater accuracy. Pilots often faced dangerous conditions. Anti-aircraft fire, unpredictable weather, and mechanical failures were constant threats. Yet despite these dangers, reconnaissance flights proved the strategic value of aircraft, providing information that could turn the tide of battles and save thousands of lives. In addition to reconnaissance, the first American pilots participated in aerial photography missions. Using rudimentary cameras, they captured images of trenches, roads, and enemy encampments, which were then analyzed by military strategists. These missions required precise flying and coordination with ground forces. Pilots learned to navigate using maps and landmarks, communicate observations, and adapt to rapidly changing situations in the sky. These experiences laid the groundwork for modern aerial surveillance and intelligence-gathering operations. As the war progressed, the United States began deploying fighter aircraft. Early models were primarily used to protect reconnaissance planes from enemy attacks. Pilots engaged in dogfights, aerial battles with opponents requiring agility, speed, and quick decision-making. Aircraft were still fragile, often constructed from wood and fabric, and armed with only basic weapons. Nevertheless, these missions demonstrated the potential for airplanes not just to observe, but to influence the outcome of combat directly. The tactics developed during this period became the foundation for future air combat doctrine. Training remained a central focus. American pilots were sent to Europe to learn from experienced French and British instructors. These programs emphasized formation flying, gunnery, navigation, and emergency procedures. Cadets practiced maneuvers that would allow them to evade enemy aircraft, protect reconnaissance planes, and coordinate with ground forces. The rigorous preparation was essential. Early combat losses were often due to inexperience rather than enemy fire. By the end of the war, the United States had trained hundreds of skilled pilots capable of operating in challenging conditions. Aircraft technology continued to advance rapidly. Engineers introduced stronger airframes, more reliable engines, and synchronized machine guns that allowed pilots to fire through propeller arcs without damaging the aircraft. These innovations increased both effectiveness and survivability in combat. Planes like the Spad-13 and the Nieuport 28 became symbols of American aerial capability, combining speed, maneuverability, and firepower. Each technological leap reinforced the strategic importance of aviation and demonstrated the potential for dominance in the skies. The integration of air power into military strategy transformed traditional warfare. Commanders learned to coordinate artillery strikes with aerial reconnaissance, anticipate enemy movements, and deploy troops more efficiently. Aircraft became essential tools for both offense and defense. The psychological impact was also significant. The presence of airplanes above the battlefield altered enemy behavior, introduced a new dimension of uncertainty, and increased the visibility of military operations. Air power was no longer an experiment, it was a force multiplier. One of the most notable contributions of U.S. aviation during World War I was the development of tactical doctrines for combined arms operations. Pilots worked closely with infantry and artillery, adjusting bombardments based on real-time observations. Communication between air and ground units improved dramatically, often using signal flares, radios, or message drops. These experiments demonstrated the value of integrating air power into broader military strategies, a concept that would dominate warfare in the decades to come. The war also highlighted the human cost of early combat aviation. Pilots faced extreme danger, limited protection, and the constant risk of mechanical failure. Fatalities were high, yet their bravery and skill set enduring standards for future generations of aviators. Stories of heroism from pilots completing dangerous reconnaissance missions to daring dogfights above enemy lines captured the public imagination and elevated aviation as a critical component of national defense. By the end of World War I, the United States had transitioned from a fledgling air program to a force capable of contributing meaningfully to international conflict. While initially reliant on European designs and instruction, American engineers and pilots had gained invaluable experience, developing new technologies, tactics, and operational strategies. The lessons learned during this period shaped the future of U.S. military aviation, setting the stage for the development of an independent air force and establishing the airplane as a decisive instrument of war. In summary, America's entry into World War I marked the first true test of military aviation on a global scale. From reconnaissance to aerial combat, from photography missions to the coordination of artillery and ground forces, aircraft reshaped both strategy and tactics. The bravery of pilots, the ingenuity of engineers, and the vision of military planners combined to create a new dimension of warfare. The sky, once a frontier of dreams, had become a battlefield, and the United States had firmly taken its place among the nations exploring this revolutionary domain. From pioneers to air power, the legacy of early U.S. military aviation. The guns fell silent in 1918, but the roar of engines continued to echo across military bases. The airplane, once a fragile novelty, had proven itself as a strategic instrument of war, and America was only beginning to understand its full potential. After World War I, the U.S. military faced the challenge of transforming wartime aviation successes into a permanent, organized air capability. The conflict had demonstrated that aircraft were more than mere curiosities or adjuncts to ground forces. They were instruments that could shape battles, gather intelligence, and influence national security. Military planners, engineers, and policymakers began envisioning a future in which air power would play a decisive role in both defense and offense. One of the first steps in this transformation was the formalization of military aviation structures. The U.S. Army Air Service, created during the war, laid the foundation for a more autonomous aviation branch. Leadership recognized the need for a dedicated organizational framework to oversee aircraft procurement, pilot training, maintenance, and strategic planning. The Air Service became a laboratory for innovation, where new tactics, flight procedures, and operational doctrines could be developed and tested without the constraints of traditional ground-based command structures. Technological advancement remained a central focus in the post-war years. Engineers experimented with all-metal aircraft, replacing fragile wood and fabric designs with stronger, more durable materials. Engines became increasingly reliable and powerful, enabling higher speeds, longer ranges, and heavier payloads. Innovations such as enclosed cockpits, advanced navigation instruments, and radio communication systems improved both safety and operational effectiveness. These developments allowed aircraft to operate under more diverse conditions, from night missions to adverse weather, expanding their strategic utility beyond the limitations of World War I. Pilot training programs were also modernized. Recognizing that future conflicts would demand highly skilled aviators, the military established more rigorous curricula, combining technical instruction with practical flight experience. Cadets learned advanced navigation, formation flying, and tactical maneuvers, while also studying aerodynamics, engine mechanics, and emergency procedures. By professionalizing the training process, the U.S. ensured that pilots would not only survive but thrive in increasingly complex aerial environments. During the 1920s and 1930s, the U.S. military began conducting large-scale exercises to test new concepts in strategic bombing, reconnaissance, and rapid troop deployment. These exercises demonstrated the potential of air power to project force over long distances, support ground operations, and respond swiftly to emerging threats. Observers noted that airplanes could bypass traditional defenses, strike targets previously considered secure, and provide commanders with unprecedented situational awareness. Such experiments reinforced the idea that control of the skies could become as decisive as control of land or sea. The interwar period also witnessed the rise of aviation culture in America. Air shows, record-breaking flights, and public demonstrations captured the imagination of civilians and inspired a new generation of engineers, pilots, and enthusiasts. Figures like Charles Lindbergh, Amelia Earhart, and Jimmy Doolittle became national icons, bridging the gap between military and civilian aviation. Their feats highlighted both the technological possibilities and the human daring inherent in flight, reinforcing public support for expanding the nation's air capabilities. A significant milestone came with the passage of legislation that would eventually lead to the independent U.S. Air Force. Advocates argued that air power required autonomy to develop doctrines, allocate resources, and plan operations effectively. Debates within Congress and the military focused on whether aviation should remain a branch of the Army or become a separate service. By highlighting lessons from World War I, including the critical role of reconnaissance, strategic bombing, and air superiority, proponents successfully made the case for an independent, professional air force capable of both defending the homeland and projecting power globally. The legacy of early military aviation was evident in doctrine and strategy. Commanders understood that airplanes could not only gather intelligence but also shape battles, deter aggression, and provide rapid response capabilities. Concepts such as air superiority, combined arms integration, and strategic mobility became central to U.S. military planning. Even as technology evolved with faster engines, heavier bombers, and eventually jet propulsion, the foundational principles established by early aviators continued to guide decision-making and operations. Furthermore, the lessons of early aviation extended beyond technology and tactics. The experiences of pilots, engineers, and commanders demonstrated the importance of adaptability, innovation, and resilience. Early aviators had flown in rudimentary machines, faced unpredictable weather, and confronted the limits of human endurance. Their courage and problem-solving skills became part of the cultural DNA of U.S. military aviation, shaping training programs, leadership development, and organizational values for generations. The global impact of U.S. aviation developments during this period was also significant. Other nations closely observed American innovations, including long-range flights, aircraft design improvements, and training methodologies. The United States emerged as both a technological leader and a strategic thinker in aviation, influencing international air power doctrine and laying the groundwork for future alliances, joint exercises, and military aviation collaborations. By the late 1930s, the United States had established a robust aviation infrastructure, including airfields, manufacturing facilities, training schools, and research laboratories. The U.S. military possessed a growing fleet of modern aircraft capable of reconnaissance, transport, bombing, and fighter missions. The combination of technical expertise, trained personnel, and strategic doctrine positioned the nation to respond effectively to the challenges of World War II, which would test and expand the capabilities of air power on an unprecedented scale. In conclusion, the post-World War I era transformed American military aviation from a pioneering experiment into a structured, professional force with strategic significance. The innovations of engineers, the courage of early pilots, and the foresight of military planners established principles that continue to influence aviation today. From fragile wooden planes to durable metal aircraft, from improvised airfields to organized bases, and from individual daring flights to coordinated air strategies, the United States had created a legacy that combined technology, human skill, and strategic vision. The story of early U.S. military aviation was not just about machines, it was about ambition, ingenuity, and the determination to conquer the skies, a determination that would shape the future of warfare and national defense for generations to come.